Hey guys, this video is just going to basically be me explaining all the crazy stuff happening in this diagram of a voltaic or galvanic cell. So first off, you can see that there's no external voltage required. We don't have a battery or something like this charging the whole reaction. We just have a light bulb that shows that it's going on. And the reason you don't need any external voltage source is because this is a spontaneous redox reaction in a galvanic cell. This reaction is going to be spontaneous because of the difference in reduction potential of the cathode and the anode. So the cathode is going to be whichever of these two metals has a higher reduction potential. You can look that up on a table of standard reduction potentials. And on the right side, we see the anode is just going to be whichever has less reduction potential, a lower reduction potential. Now, the cathode is going to be gaining mass because of this reduction formula going on right here, where positive X ions that are floating around in this solution are going to combine with electrons coming over here from the anode to form this solid X metal that's going to be deposited on this plate to increase its mass. On the right side with the anode, we have an oxidation reaction occurring, and it's going to be losing mass because this solid metal is going to be contributing electrons to this flow over here and positive ions to this solution. Now what's going to happen is that this solution is going to end up pretty positive because of all the electrons being lost and the positive ions created, and this solution is going to end up being pretty negative because of all the electrons gained and the positive ions lost to be deposited as solid metal here. So what we need to do to connect this circuit and keep the charges all balanced is have this salt bridge in the middle. I have it as KCl, potassium chloride, because that's a very common salt bridge. KCl is a good salt bridge because it's a strong electrolyte. That just means that it's a good conductor of electricity. That's an ionic solution or salt. Salt, ionic substance, basically same thing. Now, it also has to be inert, meaning it doesn't react with the other particles. We don't want it interfering with these reactions going on at the cathode and anode. So, also, a salt bridge is going to contribute the positive ions over here so that this gets more positive after gaining electrons, and the negative ions over here so that this gets more negative after losing electrons. And this salt bridge can either be a U-tube with the aqueous solution inside of it, or just filter paper soaked in the electrolyte so that it can have these ions flowing to replenish the charge and make sure that electricity can flow all the way around.